decade ago, we thought robotics to be just a fantasy. From the very ancient time, we have seen telos which appeared in the Greek epic. It was then like it extended to the sci-fi movies in 1990s where we had Terminators as the powerful weapons, iRobots as helpers, Ex Machina which can do errands for us. But now we have took a deep step into the robotics, and now we are turning those fantasies into realities. Be it Automaton, which is a self-operating robot, be it Sophia, which is replicating human actions, or be it Asimo, which can perform various complex tasks. So now we are moving towards the humanoid industrial robots, and we have already been like a way ahead, and there are a lot of things that needs to be done.
What is robotics? There are many ways to define this, but at its simplest, it is the science and the study of robots. Robotics involves the conception, the design, the manufacturing, and the operation of robots, on top of the computer systems that is used for control, sensory feedback, and the information processing of the robots. Due to all the underlying components of a robot, this field overlaps with many other fields, such as electronics, computer science, artificial intelligence, mechatronics, nanotechnology, and bioengineering. In essence, robots are man-made computerized machines that performs tasks on human command or by themselves and seeks to make work easier for human beings. They are built to be a substitute for humans and be able to replicate human actions. Robots are multi-purpose and are able to be used in a wide variety of situations, but are generally used in hazardous situations that are ill-suited for human presence. These involve situations or environments that do not allow for the survival of human life, such as environments of extreme heat or even lack of oxygen.
Robots come in many shapes and sizes, and many robots today are built with inspiration from nature, but some are made to resemble human appearances as influenced by classical sci-fi movie and other movie cultures.
As mentioned earlier, robots are an amalgamation of various fields of study. From mechanical engineering, the machine is studied in static and dynamic situations. By means of mathematics, the spatial motions can be described. Tools for designing and evaluating algorithms to achieve the desired motion are provided by control theory. Electrical engineering is helpful when designing the sensors and interfaces for industrial robots. Last but not least, computer science provides for programming the device to perform the desired task. As such, there are challenges that must be overcome in each and every field in order to develop a modern robot as you see today. For example, we can see that the first industrial robots were pneumatic or hydraulic. These were suitable for working with heavy loads, but were very clunky and rough in their motions, making it unsuitable for detailed or delicate work. Especially if the robotics were to be applied for other purposes such as assembly work on a factory line, which typically required precision and accuracy. Material handling, such as gears, motors, and actuators, are fundamental to robots, but the next generation autonomous robots are using state-of-the-art breakthroughs with artificial muscles, soft robotics, and assembly strategies to be multifunctional and more power efficient.
Cool.
Power sources is also a key factor. Today's robots have a wide variety of power sources, some more compact for portability, and some use generators for tasks that are more demanding, such as factory work. But regardless of which power source is being used, experts can typically agree that robots are typically energy inefficient. As such, improving the battery life is a major issue to be considered by either improving the battery technology to be beyond the nickel metal hydride and lithium ion options, or to make the components of a robot more energy efficient.
Now we are going to discuss the software development environment and types of robots. Robotics in relatively to other branches, actually new domain of engineering. It's a multidisciplinary domain, and the different branches occupied by robotics are mechanical engineering, electrical engineering, and the computer engineering. Actually, robots are categorized depending on their applications. So, if you wanna categorize them basically on applications, there are four main categories. First of them is industrial robots, and the second is autonomous mobile robots, and the third one is humanoid robots, and the last one is educational robots.
Actually, there are three main environments for the mobile robots that require significantly different designs. Principal because they differ in mechanism of motion. Like for aquatic, there are like underwater exploration. For terrestrial, we have cars. For aerials, we have drones. Again, the classification is not strict. For example, there are amphibious robots that can move in the water as well as on the land. Robots for these environments can be further divided into subclasses. Terrestrial robots can have legs or wheels or sensors, tracks, and aerial robots can be lighter than air, like maybe even lighter than balloons or heavier than the aircraft, which are turn divided into fixed wings or rotary wings as we see in the helicopters.
Nowadays, people started creating new robots for educational purposes. It made the branch of educational robots quite popular because, based on educational robots, people start training new stuff and new scientists who gonna push this field of robotics.
Basically, advances in the electronics and mechanics have made it possible to construct robots that are relatively inexpensive. Educational robots are used extensively in schools, both in classrooms as well as in extracurricular activities. The large number of educational robots makes it impossible to give a relatively complete overview. Here we give few examples that are representative of robots commonly used in education.
Yeah, many educational robots are designed as pre-assembled robots. Like, for instance, we can talk about Themio from Mopsia Company and the Dash robot from Wonder Workshop. Also, these robots are relatively inexpensive, and their robots are also inexpensive, and they contain a large number of sensors and the output devices, such as lights, for instance. An important advantage of these robots is that you can implement robotics algorithms out of the box without investing hours in mechanical design and the construction. However, pre-assembled robots cannot be modified. Though many do support building extensions using, for example, Lego components. And the Lego Mindstorm robotic kits were introduced in 1999. A kit consists of standard Lego bricks and the other building components, together with motors and the sensors, and the programmable brick, which contains the computer that controls the components of the robot. This kind of robots can perform as a flexible robots, and you can design and build the robot for specific task limited only by your imagination.